All right, welcome back. So we will continue on interface testing. We talked about the interface testing in general and the types. Now we have interface testing guidelines. We talked about interfaces as not graphical user interfaces, but the endpoints that a component or a system could communicate with the other components or units with other units. So test cases actually would test those interfaces, and in general, testing should apply, or so we should select test cases where we could push the system to its limits. So let's say in the call procedures, we use extreme ends of their ranges. So we should design test cases that would test the procedures at their extreme ends. And we got an example earlier about the age. What would the system do if someone registers with and selects the age is very low, like 2 years old? And that's an extreme edge. Also test pointer parameters with null pointers, as pointer parameters are troublemakers, because once they are null, they produce errors if they are not handled properly. So we test pointer parameters with null pointers and see how the system would respond if it is designed properly and exceptions handled properly. It will show messages rather than crashes. Also, we should design tests that cause the component to fail. So we try to on purpose make the component fail and see what makes it fail, so we could recommend a solution. Stress testing in message passing systems, and this is important to understand the limits of or the capacity of a system, of a component, on receiving or sending messages. So some systems are designed to service tens of users at the same time. Other systems are designed to service tens of thousands of users at the same time. So this stress testing help us know how many users can use the system at the same time, and if those components are using shared memory, then vary the order in which components are activated. In means we should try to understand or try to test how components are actually handling the shared memory. So we talked about unit testing, we talked about component testing, and now system testing. It involves integrating components, all the components that form a system, which would create a version of the system, and then we test that integrated system. Our focus in system testing is testing the interactions between those components. And we check at system testing, we check the compatibility interaction among those components, and whether they are having a correct interaction or not, and transfer right data at the right time from a component to another through their interfaces. So system testing would evaluate the behavior of the system, mainly the interactions between the components. So system and component testing can be implemented at the same time. So during system testing, we may have reusable components that have been developed separately in previous time, or an off-the-shelf systems, some third-party systems that we just integrate with our system, and we call our new components newly developed components. So the system may be formed from these three types of components, and then our test would take place on all of them. The components developed by different team members, or let's say sub-teams, may be integrated at this stage, the system testing stage. And system testing is a collective rather than an individual process. Again, what we try to do in system testing is to test the behavior of the system and the communication or intercommunication between its components. We could utilize use case testing as well, where we write use cases and then evaluate the system based on these use cases. And use cases are developed to identify system interactions where it can be used it could be used as a system testing strategy. So each case usually involves several system components, and the testing would force the use case would force those interactions to happen among those components. Sequence diagram is one of those the UML diagrams that clearly represent these interactions. And have a look on this sequence diagram. It is for collecting weather data. So you can see we have the weather information system and the system components. We have the satellite communication, weather station, communication link, and weather data. Each of those are components of the system, and the arrows in all directions are communications among those components. So it starts with the user requesting a report, and then the satellite communication acknowledge receiving that request, and it would start communicating with the other components to collect the data. And then once the data is collected, it would be sent, the report would be sent to the weather information system. So this is a use case that helps us to test the system by testing the interactions among its components. Now, testing is something that testing a system is something that is huge, and exhaustive system testing is almost impossible. So we should maintain testing policies in order to know and prioritize our tests. So we have some 3 examples here of system of testing policies, such as all system functions that are accessed through menus should be tested. This policy says that the functionalities available through the graphical user interface menu should be tested. And this would actually help us put a frame or time frame on the testing activities that we would like to have. So a testing engineer or software engineer should build testing policies in order to size and limit the time spent on testing according to the needs and requirements of the users. There is a method of development called test-driven development, and it's referred to TDD in short, which interleave testing and code development happen. Means testing goes all the way with code development from the beginning of the system development, and tests are written before code, in fact, and then once the code is developed, the tests would be evaluated. So this kind of development is called or categorized as incremental development, and the development grows with test cases. We don't move to the next increment until the code has passed the test. And test-driven development falls under the agile development methods, such as extreme programming, while it could be as well related to plan-driven development processes, but it was introduced under agile development methods. And here is a diagram illustrates the test-driven development. You can see we write a test first and then run the test. If the test fails, then we implement the functionality or we refactor. If the feature is not there, we implement the functionality. If it passes, then we identify new functionality, and then we write a test, and then we go through the loop again. So TDD development has process activities. It starts by identifying the increment, as we have seen in or the functionality, and then we write the test for the functionality and we implement it. Then we run the test. If the test is successful, we go to the next increment or next functionality. If the test fails, we refactor or we update the functionality. Test-driven development has several benefits, and these four are the most important ones. Code coverage, where every code segment that we write has one associated test. So all code written has at least one test. So the test coverage for code written is complete. Regression testing, and because of the incremental development nature of the test-driven development, regression tests suit the test-driven development, and we will talk about regression testing in a second. Simplified debugging, because when test fails, it should be obvious when the problem or where the problem lies, because we are testing the functionalities one by one. So the newly written code needs to be checked rather than going through all the code in different development models. And then it helps to produce a good system documentation, as the tests themselves are form of documentation. Talking about regression testing, and which is testing the system to check the changes have not broken previously working code. Now, in incremental development, once we go for a new increment, means we have finished developing a certain amount of functionalities, and then the second increment we would develop additional functionalities. Regression testing makes sure that the new developed functionalities did not break previous working version of the system. And in manual testing processes, regression testing is quite expensive, but with automated testing, it's simple and straightforward. So regression testing is best when